Let's look at this problem over here. We are trying to find the probability density function of a sum of two independent random variables. Now, according to our text, this density function is given by this integral called the convolution. And because both x1 and x2, they are non-negative random variables, because we can see that the density function is non-zero only for x is greater than or equal to 0. So it simplifies to be this integral over here. And for y is greater than or equal to 0. If y is less than 0, this density function is simply going to be 0. So we need to just calculate this integral over here. With these two density functions, f1 and f2, they are both taking this form over here. Now, remember when we integrate this integral over here, y is a parameter, x is the variable over here. So we want to be very careful about this. Now, look at this integral. We have f of x is a piecewise defined function because we have two pieces, this piece and also this piece. So which piece we should plug it in over here? We need to write down our reasons over here. So we see that this is what we have. Since in the integral x is less than or equal to y, bigger than or equal to 0, we see that one over here. So we have the following thing. We have y minus x. This part over here is greater than or equal to 0. Is greater than or equal to 0. So if this is true, then we know f of 2 y minus x is going to use this piece only. So it's going to be 2 and then exponential function, and then we have negative over here 2, and then we have y minus x over here. Just replace x over here by y minus x according to the rule of composition. So this is this part, and then we do the other part using the same reason. Look at this x. X is between 0 and y. That means x is greater than or equal to 0. So we have the following thing. We just copy this reason over here again. Since x is greater than or equal to 0, so we have f1 of x is again just this branch, not this one over here. So we have twice, and then e to the negative 2 and y no longer y, so it's just going to be x over here. All right, so this is going to be negative 2x. Let me erase this part. So over here, we simply should have negative 2x. All right, now we are ready. We're going to plug in these two functions inside, so we have the following. So we have h of y is equal to, from 0 to y, and twice of e to the negative 2 and y minus x. So this part is over here. And then we multiply this expression by f1, and that's going to be 2 and e to the negative 2x and dx. Now we're going to combine these two functions together according to the rule of exponential functions. This is what we have. 4 is a constant, so it can be pulled out. We have 0 over here and a y over here. And then we have exponential function, negative 2y, and then we distribute 2 over here, we get plus x. And then because these two over here are multiplied together, so we have over here again e to the negative 2x dx. Okay? And we see positive 2x and negative 2x, once we combine these two exponents, they can cancel. So what we have over here is 4 times from 0 to y and e to the negative 2y. And this part is dx. Y is a parameter, it's a constant, so we can actually pull this one simply out. So it's 4e to the negative 2y and integrate from 0 to y. And then we have just dx. Integrate this one is going to be simply y. So we have 4y and e to the negative 2y. And that's for y greater than or equal to 0. And we already mentioned that this random variable y over here is non-negative. So its density function for the other part of the interval is going to be simply 0 when y is less than equal to 0. Everything is going to be 0. So now we have the density function for this sum of two random variables, independent ones. We have the following. So eventually we have the probability density function of y is the following. It's h of y. It has also two branches. One is 4y and e to the negative 2y when y is greater than or equal to 0. And it's going to be 0 if y is less than 0. If you try to sketch a diagram, it looks like this. This is going to be y, and this is going to be h of y over here, h of y. So it's going to be 0 over here, and then it actually picks up something like this, and then it goes to 0 when y is going to infinity. Okay.